Hi everyone. In this video I'm going to demonstrate multi-level binary logistic regression using jamovi. Before we get started, I want to note several things. First, the demonstration is based on an example and data that's associated with Hox's 2010 book, Multi-Level Analysis Techniques and Applications. You can obtain a copy of the SPSS data file that I'm using in this video. Basically, you're able to read it directly into jamovi by following this link right here, and I will make this link available underneath the video description. Additionally, I will make a link available to this PowerPoint that you see opened up on your screen as well. And this PowerPoint actually is going to contain a lot more detail regarding interpretation than I'm going to go into in this video demonstration. So let's go ahead and get started. So for our example or scenario, we are predicting the likelihood of a child repeating a grade during their primary education. So we have students, basically primary students, who are nested within various schools. So the level 1 outcome variable is going to be this variable REP1 that you see right here in the screenshot. It's basically coded 1 for child repeated a grade during primary education, 0, the child did not repeat. The variable male is a binary variable indicating whether a person was identified as male or female. Females were coded 0, males were coded 1. Then we have this PPED variable. It's a binary variable indicating whether a child had preschool education. So it's coded 0 for no and 1 for yes, and that's this variable right here. The level 2 variables include a school level identifier, which you see right here in the screenshot. And then we also have this MSESC, and this that's this variable in the data set. You don't see the entire word, but basically this is aggregating student socioeconomic status within schools. So it's basically the average socioeconomic status associated with students within a school. You'll notice that in the first part of the output, the first few rows do not contain any kind of data. This was actually just how it was read in from the original data file, so I'm not sure why there's missing data, but when I downloaded it from the book site, that was missing. So but you'll see down below there's more values actually appear for that particular variable. Now we also have this PPED underscore mean and this male underscore mean variable as well. So it's these two variables in the data set. And these variables are not actually in the original data set or the example provided by Hox, but I went ahead and created them for the purposes of this demonstration. So the first variable, the PPED underscore mean, is representing the proportion of students in a school who had preschool education, and then the male underscore mean variable represents the proportion of males at a given school. So opening up our data set, you can see right here we have the school ID variable, male, PPED. There's our REP1 variable reflecting whether or not a student had been retained. There's our school aggregate for socioeconomic status. You can see the values start to fill in at about school 10103. There's our proportion of students who attended preschool, and then the proportion of males variable as well. So before we actually begin running our analysis, let's look at a couple of things. First, this variable right here, you'll see that there's a ruler next to it, and this is indicating that the variable is being recognized by the program as continuous. So I want to make this or change this so that it's recognized as a categorical variable. So I'm double-clicked on that heading, and I'm going to click right here for nominal, and you can see that the levels are represented, basically level 0 and level 1 right there. So now I'll hit the hide button, and you can see our variable now is registered as nominal. So that's the first thing that I want to mention. The second thing is that in order to run the analysis, you're going to need this particular module right here. This is a linear models module. Now if you have not already installed this, you're going to need to do so. So just to kind of show you where to go, on the screen here, at the very right of your screen in jamovi, there's a plus sign, and it says modules, and you pretty much cannot see it probably in this particular video, but there's a plus sign that's given right here, and I'm just kind of drawing over it. But basically, if you hit that, you can go to Jamovi library, and then these are different modules that you can install. So the module that you'll need to install, and I've already installed it right here, is this GAMLJ module. And that's going to allow us to perform our analysis. So once that's installed, you'll get the icon showing up that says linear models, and so we're pretty much ready to go. So I'm going to go down to generalized mixed models and click that button, and you'll notice that it says categorical dependent variable logistic that's given. And what I'm going to do is we're just going to stick with that, and we're going to move the school identifier variable down to the cluster variables box. We're going to move the repeat variable over to the dependent variable box, and we're going to go ahead and move the male variable, PPED, and our school aggregate for socioeconomic status down to the covariance box. So we're going to try to mimic the first part of the demonstration from Hawks's text. So next, what we're going to do, I'll go ahead and show you. If I click on fixed effects, whatever I put into the covariance box is going to show up under fixed effects. You'll notice to the right there are no values showing up in that output yet, and the reason why is we haven't specified random effects. So I'm going to click on random effects, move the intercept over to the random coefficients, and now you can see that various estimates start to be computed, and then ultimately will appear, as you can see right here. Next, I'm going to go ahead and scroll down, and under covariate scaling, just to remain consistent with the presentation, you'll notice that in Jamovi they default as centered, and what I'm going to do is select none, again to mimic the Hawks presentation. Now another thing that I want to mention too is that obviously our male and our preschool education variable, both of these were binary variables, so technically we could have just treated them as factors, or we could treat them as covariates. Both of these are being treated essentially as dummy coded variables that are being included in the analysis. So now we've specified everything, and now we're ready to interpret our results. So when we're looking at the output, you'll see first off that there's some general model information. You can see that we've got the log likelihood. We've got two of these R-squared values. These are basically pseudo R-squares. You've got a marginal and conditional. You've got the Akaike's information criterion, Bayesian information criterion, deviant statistic, and residual degrees of freedom. A lot of folks are interested in the pseudo R-square values. So just really quickly, just to let you know that the R-square marginal represents a percentage decrease in the error of approximation based on the fixed predictors in the model, and then the R-squared conditional is indicating the percentage decrease in the error of approximation based on the set of fixed and random effects. So again, these are basically kind of like pseudo R-square values in that they're not computed in the same way that we are used to with standard least squares regression. But we can interpret the marginal R-squared as indicating that the inclusion of the fixed effects increases our ability to predict retention by 3.9%. And just so you know, there's not a whole lot of documentation that I found on these particular R-square indices, but you'll notice that I've got these little links in here in blue that are provided, and these give you some direction about where to go to learn a little bit more about them and how they're being used in this particular context. Next, looking at our model results, you can see that we have fixed effects omnibus tests, fixed effects parameter estimates. Most of the time I tend to go to this area right here for the fixed effects parameter estimates, and you'll notice that we have our three predictors, the male, PPED, and then our school aggregate for socioeconomic status. So in the estimates column, these are the regression coefficients. You can see that we have our standard errors. This right here is reflecting a column of odds ratios that are provided, as well as we have a 95% confidence interval for the odds ratios, z values, and p values. So in the PowerPoint I go into a lot more detail about unpacking what these things are actually meaning, but kind of loosely speaking, let me just say that because this value, because male is coded essentially 0 for female and 1 for male, then that positive regression slope is indicating that males were at a greater likelihood of being retained than females, and you can see that that effect for the male variable is statistically significant. The PPED variable is reflecting again whether or not a person had experienced preschool education. So basically a value of 0 represented no or none, and a value of 1 represented yes, or did have preschool education. So the fact that this regression coefficient right here is negative is indicating that students who had experienced preschool education were less likely to be retained during primary school than those who did not experience preschool education. And you can see the effect of that variable is statistically significant as well. The school average variable that you see right here, we have a negative regression coefficient. So the average school socioeconomic status was negatively predictive of the likelihood of retention, and basically students in schools that had higher average socioeconomic status were less likely to be or to experience retention than those with lower school average socioeconomic status. But you can see that that predictor was not statistically significant in the model. Then in the random components table, you can see that we have a variance estimate for the intercept. So you can see the standard deviation and variance estimates that are given right there. Now with respect to level 1 residuals, there are no level 1 residual variances that are being estimated, and that's because the underlying probability distribution that's associated with the binary outcome is not normally distributed. So that's why these values right here are fixed at 1. So there's not really much to interpret with respect to the residual standard deviation and the residual variance. Okay, so a limitation of our previous model is that there was no control for between school differences on the predictors at level 1, and so the slopes for the within group effects of the level 1 predictors could be biased due to a conflation of the within group association and between group association between the level 1 predictors and the outcome variable. So to account for this possibility, I'm going to add in school level means or aggregates for the male and PPED variables. So that's where we're going to have our PPED underscore mean variable and male mean variable added. And you can see right here that we're essentially leaving everything else exactly the same, except now we're entering these variables. I'm also going to treat these variables as being centered as well. So let's go ahead and do that. So to do this, we're going to go up here and move our 2 additional predictors over into the covariance box. And we're going to scroll down, and under covariate scaling, I'm going to go ahead and just hit centered right there for that. The other 2 actually defaulted using mean centering or grand mean centering. So now we have to the right, you can see our output. And so again, you can see up here we've got our model info that's given. These are our 2 pseudo R-square values I was telling you about before. Under model results, there's the fixed effects omnibus test and the regression parameters that are being estimated. Down here, these tests are being carried out using the walled Z. And then scrolling down a little bit more, you can see there's our random components given as well. So looking at our table of the regression coefficients, looking at the estimates column and our predictors, you can see right here for male, you can see we have a positive regression coefficient right here. You can see that that predictor is statistically significant, indicating that males were at a greater likelihood of being retained than females during their primary years. The PPED variable, you can see that regression slope is negative. We can see that that's significant as well, indicating that students who experienced preschool education were less likely to be retained during their primary school years than those who did not have preschool experience. You can see that our school aggregate socioeconomic variable right here, there was a negative regression coefficient, but you can see it's not statistically significant. Because that coefficient is negative, let's just go ahead and really just quickly interpret that to mean that had that been significant, that would be an indication that students attending schools that were higher in average socioeconomic status would have been less likely to be retained than those students in schools with lower average socioeconomic status. You can see that our proportion of students within schools who attended preschool, that predictor was you can see it's positive, but it's not statistically significant. And then the proportion of males within schools, you can see that we had a negative coefficient here, but that's not statistically significant. So basically the results largely mirror what we found before with respect to the effect of the gender variable and the proportion of, and then the variable reflecting whether or not a student had experienced preschool education. And just to reiterate, as I noted before, in the PowerPoint that accompanies this video, you'll find a lot more detail regarding the interpretation of the specific coefficients in this particular table. Okay, so one additional model that I want to show you, and this again is not included in the Hawks presentation, but basically I wanted to demonstrate that you can allow the slope for your level 1 predictors to randomly vary across schools and then estimate a variance component for that. We're also going to model a cross-level interaction. So you'll see right here in the screenshot under random effects, you can see I've added in a random coefficient for the male regression slope. So we're essentially treating the regression slope for the male predictor as varying across the schools. And then under fixed effects, you can see I'm laying out or specifying an interaction, a cross-level interaction between the level 2 measure of school level socioeconomic status and the level 1 predictor for male. So going back into Jamovi, let's go ahead and do this. So we're going to, first off, I'm going to go under random effects. I'm going to move this male variable over to the random coefficients box. Under effects correlation, I'm also going to specify not correlated. That just kind of simplifies the model a little bit and kind of speeds up the processing a bit. And then under fixed effects, I'm going to highlight male and then our level 2 predictor right there, the school average SES, and then I'm going to click on this button right here and then click interaction. Okay, so we have our output showing up in the panel on the right. Let me just kind of note it took probably about 30 or 40 seconds for this to finish computing, but it is up now. And just kind of looking at our output, you can see that many of the results hold as before, but you can see that we have our interaction term that's given down here, and you can see that the test of the interaction term is indicating that the cross-level interaction is not statistically significant. So if it had been statistically significant, then we may have wanted to probe the interaction by going down a little bit further, and you can see we've got under as additional Jamovi options, we have plots, so we could plot out the simple slopes, and simple effects, we can actually test the simple slopes using these options here. So to give you sort of a picture about what this would look like, what I'll do is I'll just go up here under plots. I'm going to move the male variable to the horizontal axis and then our level 2 predictor to the separate lines right here. And you'll see that a plot appear. And then for simple effects, I'm going to move the male variable to the simple effects variable, and then the moderator to the moderator variable. And you'll also see simple effects tests that are generated. So looking at our output, you can see under the simple effects of male at our three different levels of our moderator variable, these would be the regression slopes and the significance level. And you can see in the plot the regression lines are pretty much on top of each other. And really the main reason for this is that right now our plot, the y-axis, is reflecting probabilities from 0 to 1, and the probability of retention in general was pretty low in our sample. If I want to click on linear predictor, then I can get a little bit better picture at the relationship between our level 1 predictor and the outcome at different levels of the moderator by plotting out predicted logits, which you can see in this plot right here.